Our next presenter is Alex Chibly, and Alex is from the program in cancer biology at U of A. His major professor is Dr. Kirsten Limesand, and the title of Alex's presentation is Saving Lives One Salivary Gland at a Time.
Have any of you ever felt cotton mouth or dry mouth before? It is not pleasant. Well, now imagine you feel like that every minute of your life for the rest of your life. That is the case for Charlotte, a 65-year-old woman that I met when she was diagnosed with a tumor in the head and neck region. She received radiation therapy and her cancer was eliminated, but now, as a side effect of the radiation, she permanently lost her saliva. This happens because her salivary glands, the organs that make saliva, are also in the head and neck region, so they become injured by the radiation during the treatment of the cancer. As a consequence, Charlotte suffers from chronic oral infections, she has lost most of her teeth, she can't taste food, eating is too painful, and this has led her to require a feeding tube. As you can imagine, her quality of life is miserable, and currently there is no cure for her condition. All of this happens because of the loss of saliva. So in our lab we study how radiation therapy causes the loss of saliva, but more importantly, what can we do to fix it? Well, all of our organs have the ability to heal after injuries. For example, if we get a cut or a scratch, it heals completely after a few days. This is accomplished thanks to the function of stem cells, which are like the building blocks for all of our organs. And their main function is to continually renew our organs and heal them to maintain them in good shape. So my research question is, what is happening to the stem cells in the salivary glands that prevents them from healing the injury caused by the radiation? Using microscopy tools, I found that stem cells work very similar to batteries. They have a positive side and a negative side. We call this cell polarity, and this is very important for their function. For example, if we take these cells and put them in a dish, they're able to grow into this fully functional salivary gland-like organoid. Why? If we take the stem cells from a mouse that has received radiation, their positive and negative sides are now scrambled. They're also unable to grow. This is similar to when we insert a battery backwards. The battery itself still works, but cannot perform its function. And this could explain why patients who receive radiation therapy like Charlotte lose their saliva. So what are we doing to fix it? Well, I'm currently trying to find a way to flip the battery, restore polarity in these cells to stimulate them to heal the salivary glands and restore saliva. The immediate implication or application of this therapy is to improve the quality of life of the hundreds of thousands of individuals who, like Charlotte herself, are currently suffering from the loss of saliva as a consequence of their cancer treatment. But beyond that, I envision that a therapy like this would mark the beginning of a future in which quality of life is no longer a sacrifice to make in our fight against cancer, any cancer. Thank you.